Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be understanding a problem on statically indeterminate problem, that is coplanar non-concurrent forces. This CNCF stands for coplanar non-concurrent forces. And let us look at the problem. The problem is given here. This is a problem on with non-concurrent, and you have four identical wires. One, two, three, four. You have four flexible wires as it is mentioned, and it is supposed to support a rigid bar. So this bar is a rigid bar, and of course, it is shown in figure. If the stress is not to exceed 150 Newton per mm square, find the minimum required diameter of the wire to support a load of 40 kilonewton at point C. Observe carefully, the point C is not exactly the midpoint. If it is load is acting exactly at the midpoint, the rigid bar will be extended, or it is deformed in such a way that the deformation in A, B, C and D will be same. So then the problem is it becomes statically determinate, but it is eccentrically loaded. So because of this eccentric loading, this problem becomes statically indeterminate. And to solve this problem, let us first of all draw the free body diagram of this given system. So here the moment load is applied, a tensile force is developed in the wire A. I am calling it as T subscript A, and tension TB, and tensile force in this also it is a TC, and it is a TD. So you have four forces with the different magnitudes, obviously different magnitudes because of the eccentric loading. And now let us apply equations of equilibrium. This is clearly a coplanar non-concurrent forces. All the forces are lying in a single plane, and all the forces are meeting at different locations. Let us see that it is this is the system. It is acting at different locations A, B, C, D, and so on. So this constitutes a coplanar non-concurrent forces, and you have three equations of equilibrium. Here you have sigma fx is equals to 0, because in this particular problem no force is acting along the x direction. So this equation is no use of this particular equation. Another equation is sigma fy is equals to 0. Yes, you can apply this particular equation because the forces are tensile forces are pointing upwards positive, and 40 kilonewtons acting downwards, it is negative. So this equation is Ta plus Tb plus Tc plus Td minus 40 kilonewtons is equals to 0. So this is equation, let me call this, rewrite this equation. I am writing it as Ta plus Tb plus Tc plus Td is equals to, it is 40. This is my equation 1. Sigma Fy is equals to 0. And apply moments about point A. A is the moment center. I am writing this as sigma Ma is equals to 0. And give the sign convention. I am giving anti-clockwise turning effects are positive. So anti-clockwise moments are positive. So when you take this as moment center, so there is no moment contributed by Ta. You have Tb, Tc and Td. All these three are contributing anti-clockwise moments which are positive, and only 40 kilonewtons contributing clockwise turning effect, it is negative. So now you can write down the moment terms are known, x, x and x, it is equidistance. So obviously you have Tb, sign convention is positive, into x plus Tc into x plus x, that is 2x, plus Td into the momentum x plus x plus x, that is 3x, and 40 kilonewtons contributing clockwise turning effect. So it is minus 40 into the momentum is x plus x, that is 2x, into 2x is equals to 0. This is the moment equation, and observe carefully x, x and x get cancelled. you can rewrite this is TB plus 2TC plus it is 3TD is equals to, you write down 40 into 2, that is 80 right hand side, and this is your equation 2. And observe carefully, you have 4 unknowns and of course 3 equations of equilibrium. Your unknowns are more than the equations of equilibrium or the equations available to you. So obviously this particular system is you can conclude that it is statically indeterminate problem. Indeterminate problem. So means that you are unable to solve this problem just by using equations of equilibrium, because you have only 2 equations right now and you have 4 unknowns. It's not possible. So you have to consider the deformations, the consistent deformations. How it happens now, it is the load is not acting exactly in the middle, it is acting eccentrically. So you have deformations in all the wires A, B, C and D, and the deformations are not equal because of the eccentric loading. The lowest deformation will be in wire A, and the highest deformation will be in wire D. So let us observe carefully, let us draw and assume that this is the configuration diagram. So because of this, this bar is a rigid bar, I am drawing the neutral axis of this bar. I am just magnifying this. Let us see that you have this, you can call, let us draw a horizontal line. This is what exactly the deformation configuration you have. Let us say this is delta A, the deformation in wire A, and this is the delta B, this is delta C and delta D. Here, let us look at this. This height is delta A, and this is some additional deformation. This is some additional deformation. You want to calculate that value. Similarly, here also you have delta A, and this length is from similar triangles. This is one triangle and it is inscribed in another triangle. So triangle, the small triangle is inscribed in this, and if you assume this delta, obviously this is x plus x. So you can write down this, if you call some delta C prime, you call it as delta C prime, you want to calculate delta C prime. So here it is, you can write down this value is the base of this is x value, x divided by height is delta. For larger triangle, this is x plus x, that is 2x divided by delta C prime. You want to calculate delta C prime. So from this, you can see that it is x get cancelled. You have delta C prime is equals to 2 delta. So this value is 2 delta. Similarly, this becomes a 3 delta from similar triangles concept. Observe carefully, you have represented delta B in terms of delta A and delta. Delta C you have represented in terms of delta A and delta. Finally, the delta D, this is what is your delta D. Delta D also you have represented delta A plus 3 delta. Now you can write down these equations. Delta B is equals to, you can write down it is a delta A plus a delta, and delta C you can write down it is delta A plus 2 delta, and delta D is delta A plus 3 delta. These are the equations of extensions. And as you know very well, delta, the extension of the bar, is proportional to the load. Equation is PL by AE. So it is delta is proportional to load. Here the loads are tensile forces. You can replace as tension in B. Delta B you are replacing as the tension in B is equals to tension in A plus some additional tension without any subscript T. Delta C, you can write down TC plus TA plus 2T. And finally, TD is equals to, it is TA plus 3T. So substitute the values of tension B, tension C, tension D into your equations of equilibrium 1 and 2, and now the unknowns will be reduced to only two unknowns. Comfortably you can solve, you have two equations and two unknowns, you can solve for the unknown values. Let us substitute in equation 1, your TA plus TB is TA plus T plus TC, TA plus 2T, and TD, that is TA plus 3T, is equals to, it is 40, is equals to 40. And rewrite this. You have TA, 2 TA plus TA, 2TA plus TA. You have all put together 4TA plus T plus 2T, 3T plus 3T. So it is 6T is equals to 40. This equation, call it as equation 3. Now substitute in equation 2. You will be having TB value as TA plus T plus 2 into TC. TC is TA plus 2T, and it is 3 into TD is TA plus 3T is equals to 80. So this you can write down TA plus 2TA, 3TA plus 3TA. It becomes 6TA plus here T plus 2 into 2, 4T. 4T plus 1T, it is 5T. 5T plus, it is 3, 3 is 9. 5 plus 3, it is 14. 14T is equals to 80. This is equation 4. Now solve 3 and 4 for T and TA values, and this equation, now you want to cancel TA. This equation you multiply with 6, and this equation you multiply with 4, and it is 6 4s are 24. It is TA plus 6 6 are 36. T is equals to 240. This is equation 3 with the multiplying 6. This equation 4 6 are 24. TA, it is plus 4 into, it is 1456. It is T is equals to 320. So this equation you are multiplying with 4, and the values are given. Now one equation, it is 3 minus 4, minus minus and minus. This gets cancelled, and this is minus 20T is equals to, this becomes minus, it is 80. So T value, from this T value becomes, it is minus gets cancelled, and you have 4. And if you substitute this T value into one of these equations, let us say equation 3, you can substitute, it is 4 into TA plus 6 into T, T is 4, is equals to 40, and this becomes 4TA plus is equals to, you can write down 40 minus 24, and this is 16, and your TA is also 4 kilonewtons. You got a T value and TA, and observe carefully, because of the deformation in the D is larger, obviously the load will be more in this. So you can calculate TD is equals to, it is TA, that is 4 plus 3 into, it is again 4. So it becomes a 4 plus 12, that is 16. So TD is the largest value. So largest value you have to consider in the design. Now that is 16 kilonewtons. 16 kilonewtons you have to consider. All other loads, TA, TB, TC will be less than TD. So your maximum load is 16 kilonewtons, and the stress is given 150, the maximum permissible stress is given. So here the here in order to calculate, it is a pi by 4 d square, that is the cross section area of the wire, into stress, that is 150, is equals to, this is what is the load, that is 16 into 10 to power 3 newtons. So if you solve this simple equation, you are going to get 11.65 mm. The diameter of the wire is 11.65 mm. I hope you understood this problem. Thank you very much.